Good afternoon, ladies and gentlemen. We take the relay for the previous session on desalination, and now we have another subject to discuss in the panel we have today. We are still waiting for the last presenter who is reaching us here. The subject to discuss now is the sustainable desalination and advanced water reuse, how the development and trends leading to energy and cost reduction. There is a very good target who is related with the real water costs, and we have 5 panelists just to join us, just to have a good debate today. I think the best is just to, we have a lot of topics you can see in your pads now. Even we have also the CV of every speaker. So first we start at the previous session just to do a statement from our invited panelists. I'd like just to invite the first statement to Michel Canet. Michel Canet is a business development advisor today, but a few months ago was the senior vice president of major project groups in Veolia Water Technology. It's based in France, and she's very well known in this market, and it's also an ADA director from more than 6 years ago. Michel?
Good afternoon. As Miguel said, I'm not a scientist, but I have built quite a lot of desalination plants all over the world, and I believe that also innovation and new ideas are important in our desalination market, and I think we can see forward osmosis, liquid ion exchange, and all other projects are picking up, although remaining relatively exposed to small projects. I was wondering that maybe look what we can do with already what we have, meaning that how we can be more sustainable and be cost and energy reduction with what we know today. And I did one exercise, looking today that something like 50% of the MSF plant have within Middle East, something like 25 to 30 years old. It could be interesting to look at some facts. Today, I took an example of a plant of 100,000 cubic meter per day, meaning 4,160 cubic meter per hour. Such a plant is today requesting 520 tons of steam and 16.7 megawatt of power. If today you decide to replace this plant first by an MED plant, with the 520 tons of steam, you will produce something like 6,200 cubic meter of water per hour. And then we will consume a little bit energy, of course, so something like 6.2 megawatt, meaning that you will still have 10.5 megawatt on availability, which with RO technology, you could produce again 3,180 cubic meter per hour. Meaning that by replacing such plant by a combination of hybrid project MED plus RO, you will produce with the same energy something like 2.3 times the same quantity of water. So I don't think there is more examples than this one to show how you can reduce energy and reduce cost reduction. So my philosophy, and by the way, this will be done without major change of infrastructure, because the water will be taken from the same place and disposed to the same place. So no major big infrastructure associated to that. So you can see the benefit of such decision. And I take another example, which is also something that and as I say, as a person who has built a lot of desalination, was concerned by specification, I will say that the stakeholder has to consider as well more the new constraint of the water specification. Today, for instance, you still have projects where the client is asking a boron less than 1, where today the WHO regulation authorized 2.4, and I don't think people imagine the cost and the energy which creates such constraints. In addition, and I learned that a lot when I was in Japan with the megaton project presentation. There are a lot of development on certain material, piping, for instance, in particular, FRP, JRP, where you can utilize those materials, to reduce cost and also reduce energy. So my today statement is more to say, fine, innovation are good, but look at what we already could do with what we have. Thank you.
Thank you, Michel. If I well understood, I remember your first statement. Your forecast for the future is the MSF time is gone.
Yes.
Is the time of MLG an arrow?
I think so.
Okay. Our second presenter is Ghassan Ejek. Ghassan is a very well-known guy in this market because he's a former president of IDA, but he's a senior vice president of Basis Group. He's based either in Belgium and here in USA. I think you are quite interested just to talk about water use, no? Ghassan?
Thank you very much. Thank you. I have actually, just like Michel, I'm really not a scientist. I'm a simple engineer. On top of it as well, I'm old, and this light is not showing me in the best of sights, but never mind. What I needed to lead to is I'm really, I cannot multitask, and my hobby today is life. Boring people with is two things. It's water reuse and water reuse and water reuse again. And water use is part of a total integration of the water cycle, meaning that we have to do, as Michel has suggested, improve our production methods, which is easy. I mean, from tomorrow, it's simple enough to go to any plant, reduce costs by 10, 15%, or increase water by N amount of percent, simply by being case specific, look at it and change it and get on with that and do some hybridization. But more importantly is the conveyance, and we heard a lot about pumps today and yesterday, but coming back into water treatment and water use. We cannot afford to use our water once. And when I talk about water use, I talk from all aspects, economic, sustainability, and everything else. You know, it costs in this part of the world, as we know, about $1 per cubic meter to produce probably desalinated water if you look all year round. It's even more than that. And if you look at the cost of bringing the treated sewage treatment, TSE, into a similar quality of water, it's 20 cents. So every time we are throwing this water on agriculture, or unfortunately, as the task today in a lot of places, just throw it into the sea, is $1 being thrown away. Forgetting about the carbon footprint, forgetting about all other aspects of doing that. This is not acceptable and cannot be continued like we are doing. And so water use must be addressed, it must be tackled, and if you take it to its ultimate, how can we justify spending so much water? And I'll probably be shot in this room. We spend so much money on taking the sewage in Abu Dhabi in long tunnels and long way to Al Wathba to be treated by us. And we could have done it in a simple way. And then we have to, if we want to reuse it, we have to bring it back into Abu Dhabi. In the first place, we could have done a lot of smaller plants spread all over the place. We have to start putting water reuse into our planning in a more holistic approach as we are doing at the moment. Thank you.
Thank you, Ghassan, for your statement. I have a difficult question for you. You have your own money just to invest. What do you do? Go to invest in a power plant, in a desalination plant, or in a water reuse plant?
I will answer it very quickly. I think I'll make a lot more money, and I say a lot more money, and be true to myself and to my country and to my humanity if I invested in a water reuse plant.
Good answer. Thank you, Ghassan. Our third panelist is Nobuya Fujiwara-san. Nobuya Fujiwara is the Deputy Director and General Manager of the Desalination Department, Toyobo. and he's also the director of the Arabian-Japanese membrane company in Japan. I ask for your statement now,
Okay.
Fujiwara-san.
Thank you, Miguel-san. So today I would like to talk about forward osmosis technology. So forward osmosis is a new technology. And this technology has two aspects. One is energy saving technology. The other is energy generation technology. If there are two solutions, one is lower osmotic pressure, the other is higher osmotic pressure. So that, naturally, water is moving from lower osmotic pressure solution to the higher osmotic pressure concentration. By using this natural phenomena, so that, there are many applications were proposed. So one is, firstly, I would like to explain about briefly about CO2 desalination. So this natural phenomena, so all the modern water UK or some other company, for example, probably United States, proposed to energy saving desalination, CO2 desalination technology. So, for example, Torabi, a United States company, proposed by using temperature responsive polymers, they said that electrical energy consumption can be achieved less than 1 kilowatt hour per cubic meter. But also that they need low-grade waste heat. And the other, energy recovery at CO2 desalination plant. Dr. Guerra already mentioned about pressure retarded osmosis. So the CO2 brine is very high osmotic pressure, and by using also that, for example, treated wastewater, there's a big osmotic pressure gap. So using this osmotic pressure difference, energy or power can be generated. So this created energy can help to reduce energy consumption by CO2 desalination RO plant. And third one is, for example, concentration of wastewater. For example, as you know, that produced water from oil and gas industry is very high, for example, to 100,000 million per liter something. Current membrane technology such as RO cannot treat such a high concentration wasted water. But by using forward osmosis technology, if we use high osmotic pressure solution as the raw solution, so such a high wastewater treatment, high concentration of wastewater can be treated. In conclusion, so I think that CO2 desalination and CO2 energy recovery at the CO2 desalination plant, so this FO technology can be realized in the near future, I think.
Thank you, Fujiwara-san. So, I have, my understanding, you are a very good promising technology in the forward osmosis. What do you think, what is the best application for the forward osmosis? Is going to water reuse, because part of the market is forgetting just to use it in energy production. There is a lot of application. What is your vision for the future for pressure retarded osmosis or forward osmosis?
It's so as energy recovery, I believe already, how can I say, demonstrated, proved technology. So if the CO2 brine and the wastewater is there, so easily, so energy can be recovered. So this is one of the, how can I say, realized in the near future. And next one is CO2 desalination, I think.
Just one additional question, because I remember last question, or the last statement where the governor of the CWEC was saying it's important to have a local presence. How important you feel, how is a key factor just to be a local manufacturer here? What do you think?
Yes, so that, for example, this Middle East area is a huge market. For example, as as governor of one city. So, it is natural that localized key component should be manufactured here in the largest distillation market, I believe.
Thank you for your answer. Our next panelist is Fadi Juez. Fadi Juez is the managing director of Metito. It's a very well-known company based here in the Emirates. It has a large experience in this market. For more than 25 or 30 years ago. So I think you have a short presentation. Taking my place just to do, if you like, or you are able just to handle your presentation from there.
If somebody can move it, I can do it
Yes.
from here.
Just turn to the next one. No, that's the last one.
That's a competitor.
It's Metito presentation. I think it's. Otherwise, if you like us to talk about Abengoa. Huh?
It's okay.
Okay,
It's okay.
let's go.
It's okay. Thank you, Miguel. Well, I had, as Miguel mentioned, prepare a short presentation because of the time constraint, but I go ahead and say verbally, and I'll start by taking it where Ghassan left it and raise 3 points. Number one, you look great even with a strong light, Ghassan. Number two, I had called the title of my presentation, I called it the Ignored Wealth Wastewater. And it's not anymore. This is something I used about 15 years ago when we started pushing very hard for wastewater reuse. And we used to call it the ignored wealth because it was a wealth that was practically, thank you, that was practically ignored at the time. And I think as we moved along in the last 15 years, both private and public started looking very seriously at the wealth of the wastewater and treating it and reusing it more and more. Of course, there's a lot more to be done for us, and as Ghassan mentioned, we need to do it more and more. Just to start with trends, obviously, to set the scene, we all have seen presentations about how much the population is growing, the impact of the climate change, and the cost of energy. Particularly, we saw it in the previous session. I put this slide not to look at the numbers, but to see that although in the MENA, about 35% of the wastewater is reused, okay, in irrigation and not sophisticated industrial application, but still it's a high percentage versus the world. But still 35% of 100%, and if you see at the 100% of the waste is in billions, it's a lot more that we can do with the wastewater and reuse it. Obviously, even from a commercial side, the business is growing, and you can see for the market trends that has occurred in the last few years and the years to come with the forecast, that wastewater reuse will be a real big market for companies and for private people. That's where he puts his money in the right place, Ghassan, when he puts it there. So why would we reuse? Of course, there's an environmental benefit. We have to treat the waste so that we don't impact the environment. There is a big economic benefit. Ghassan mentioned the costs. And if you compare it to the actual money we pay, it's much higher and we have much more savings. And definitely there are social benefits because we can save this wealth and keep the desalinated water for other better things. There's a variety of applications, of course, in this part of the world. We use a lot for irrigation. Most of the greenery that we have around us is by wastewater reuse. Industrial is something I want to focus on because that's where we feel is the application that has not been done a lot, and there's a major benefit to reusing it there. Of course, there's recreational. There's also the injection into aquifer. I remember Ghassan used to push a lot for that. An example is El Paso. And there is also direct potable use. We know in Singapore they do it. We know in Namibia it's actually direct. In Singapore they mix it. In Namibia they went straight into it. I will skip that. And then I want to go to an example of where we've done the reuse and it's proven. This is a project that as well talks about doing wastewater reuse in situ. You don't have to go all the way in these long pipelines and then treat and bring it back. And I give an example because it's something that happened here. It's in downtown Amar, very known place. And there they have 3 major district cooling using a lot of water. They were using a total of around 20,000 cubic meters per day. At the Dubai rate, because they have brackets and you reach the top brackets, it was costing them around 13 dirham per cubic meter. We went for the option of wastewater reuse. The space was not there. Obviously, all of us know how costly the square foot of land in downtown Dubai is, so there was no space. But then we realized that you don't need to have an empty square or rectangular area to build a plant. Membrane technology is a very simple, and you can put it in different ways and means, and you can fit it in very difficult places. So this 20,000 cubic meter per day plant of ultrafiltration, followed by reverse osmosis desalination, was built inside the biggest existing district cooling. And if you visit that plant, forget about the process technology that goes into it, but just look at the layout and the mechanics. It was fit in between the existing district cooling, and still it performed, and it's there. And guess what? They have a central tank, and they even pump this water to the other 2 district cooling, and you ended up saving 20,000 cubic meters per day, which is water for at least 80 to 100,000 people, and using instead wastewater that would have gone down the drain, reused it, brought up to relatively drinking level, and used as makeup water. Money, you went down from about 10 to 12 dirham per cubic meter that they were buying from DIWA to, like Hassan mentioned exactly, less than 20 cents per cubic meter. Imagine 13,000 times 30, 20,000 times 13, 250,000 times 30, whatever millions times 12, they paid back within a year. This is just a simple example of what we can do when we reuse the waste and use it particularly for industrial application. Thank you.
Thank you, Fadi, for your excellent and short presentation. I have a difficult question. If you are trying just to reply in an AWPP project, linking energy and water, are you going just to reply with a desalination plant or a reuse plant to sell water even for the industry?
Well, I think you need both. I think what we do in the water business, all of us, is do what nature does, but do it more efficiently. So we need to basically start something, and that's the evaporation, but then we have to treat it and reuse it. So I'll do both, to be honest with you.
So why not? No? I think that from your presentation, you have strongly believe in the future of membranes, in the advanced reuse technology from this market.
Absolutely, absolutely.
We agree to that. Thank you. Our last speaker, but not the least, is Francisco José Bernaola. He's the technical director of Abengoa Water. He's coming from Spain, has also a long experience. I know him for many years ago, more than 20, and is also the head of research and development of Abengoa Water. I think you have a short presentation, some pictures there. Now is the time just to put the Abengoa presentation. Yes.
We have been just listening about water reclamation, that is very important. We have been listening about membranes and reuse in pressure osmosis and upper osmosis, and about the new how Michelle foresees in the future with pressure osmosis and MEA. Here, I'd like to talk a little bit about how we see what's happening in the world and how we can enjoy the renewable energies with water. So, basically, we see that the public sector is pushing, is promoting the use of renewable energies. On the other hand, private sector is trying to develop new technologies in order to improve the efficiency in the production, in order to have more reliable solutions. Also, if you focus on this sector, and you can see there, this area, first of all, has plenty of energy that could gain from the sun, so we can try to take advantage of that. And on the other side, there is a very stressed area. So the source of natural water is very, very limited. So let's consider that not as a problem, but as an opportunity. Also, talking about water desalination, we have seen that reverse osmosis is the technology that allows us to produce energy at the lowest energy consumption. One of the Achilles heel of the reverse osmosis has been the pretreatment. But with the advance of the use of ultrafiltration and microfiltration membranes, I think that now we can have quite reliable desalination plants based on reverse osmosis. Another important point is that public and private sector, when they join together, they found solutions to the real problems, and those solutions are in a shorter period of time and are much more efficient. So public-private partnership is also a very interesting tool that is available. Taking into consideration that, I think that if we are able to combine the knowledge on renewable energy, if we combine that with the knowledge on water desalination and taking advantage of that public-private partnership, we can solve plenty of problems and in a short period of time. Thanks to that, there are companies that they do have internally the expertise and experience on using that renewable energy. They do have experience on water desalination, and I think that could be a good partner for any public association. Thank you very much.
Thank you, Francisco Jose. I keep it from your presentation, renewable energies, membranes, and PPP. That's the key, your key points, just to underline. Taking into account it, I presume you will be happy if in every evaluation criteria, the carbon footprint could be considered. What do you think about?
Well, carbon footprint is very much related with energy, renewable energies. And we should be
But also with energy consumption.
Yes, of course.
Huh?
Of course, we have to reduce the energy consumption because we have to reduce the carbon footprint. On that sense, any technology uses membranes and the new advances in our membranes, they are just focused on reducing the energy that is required on that. And I think we are in a good path to reduce also the CO2 footprint.
Thank you. I think we have a very good statement for 5 different points of view from our industry. We are representing the industry and not our customers, but we have covered more of the topics we are doing, the hybrid plants, the thermal plant, the reuse in both aspects, municipal and the other, manufacturing, and also renewable energies and the use of all of them. As it's an IDA panel. Almost 3 years ago, in the World Water Forum, in the 6th World Water Forum, we took a commitment just to in our industry to reduce 20% of the energy consumption in all major projects we have we have passed 3 years. We have, of course, reduced the energy consumption. What do you think that we can keep this commitment for the following 5 years? I start by Michel. What do you think?
Always the problem when you are speaking about reduction is what is the initial reference.
Yes.
So if you speak about the reference that was used a few years ago, where people were saying, it needs something like 4 kilowatt per cubic meter for RO plant, then of course I think today we are already using and working on between 3.1, 3.2, so we are nearly there. So one thing as well is, what are you comparing to, because in a desalination plant, first, you have to take the intake. If the environment constraint is calling you to build something like 4 or 5 kilometer intake, so you already have a high energy consumption just to pump the water, and then having the same for the outlet and eventually for the distribution. So I'm always careful to speak about reduction of energy. What I can say that is definitively there have been some improvement. We are using now better membrane. We are using, I think, more efficient ERI, energy recovery system. We have, I think, material which also are more performant. So the trend is there. To say that we can keep going to the same trend, I think we need to have an innovation which make breakthrough. What I mean is there are today some, if you go to forward osmosis, if you go to certain technology like that, you got already the reduction, but to which size can you apply such technology? Today is relatively limited. If you go to bigger size, is it really applicable?
I think you think that they have huge plants that is going in a better way just to have an energy reduction. But it's also valid for the MED plants?
I think MED, the big breakthrough on MED is that individual size of train has increased a lot, and obviously I can say that the efficiency is better. You are now working on a ratio of 13 or 14, where before it was 11, 12. So yeah, the trend is there.
Just to be more precise in the question, as those for Nobuya-san and Francisco, do you think that we can do the offer in the following 2 years with less than 2 kilowatt-hour energy consumption in only one pass arrow or not? What do you believe?
First, I would like to reply. So that only using arrow technology, CO2 arrow desalination, less than 2 kilowatt-hour cubic meter is, I think it is impossible. So actually, as Dr. Kurihara explained, so that the Megaton project succeed in reducing energy consumption around 22% something, but still, so the more than the 2 kilowatt per cubic meter is higher. So, and so it means also by using membrane technology, so that as concerning energy, electric energy consumption, so to achieve 2 kilowatt hour per cubic meter is only FO technology, I think. But as you may know, so that FO technology, if using temperature responsive solution, so another waste, low-grade waste heat is required. So it means total energy consumption is more than 2 kilowatt hour per hour cubic meter. But anyway, I think that only RO technology we cannot achieve less than 2 kilowatt hour cubic meter. I think. I thought.
Even if the target is very difficult, I think we should have it in mind. Using just reverse osmosis, of course, we can be closer to that, but we will not reach. But if we are able to take advantage of the chemical energy of the brine, and I mean the osmotic pressure, and we combine that with other technologies, like pressure osmosis and that, we may be not far from that figure. So the 2 kilowatt is there. I think it should be our target, and we should be very close to that, and we should try to have it in a few years, no more than 3.
Okay. There is Fadi Gassan. Do you have anything to add?
Yes, I would like to be provocative and just ask you the question myself. Here we are struggling and really doing very well, trying to get to the kilowatts for RO. And at the same time, we are conveying water left, right, and center, losing water in the pipes at a cost which is far, and with a little investment there, we can get a much better value for money than what we are attempting. I'm not saying we shouldn't attempt that. I'm saying we should get our priorities right. I will go even much further than that. I would say what Michel has just explained. If you just go and have a better production methods in the older plants, I mean, the benefits are immediate for him saying, let's get joint up thinking. Let's think integration. Let's think holistically and stop emphasizing, let's stop. We need to cut down on carbon footprint. We need to cut down on cost. we need to cut back on consumption, we need to be sustainable, and we can only achieve this by what I call joint up thinking. And unless you start thinking up correctly, outside the box, and look at all the factors involved, you will never really make an imprint on anything. So please, let's go out of this session today and start thinking beyond the box and think, joint up thinking, how are we going to get the end result right?
I agree.
Thank you.
Innovation is not only coming from the technology. Business can be a lot of innovations. Fadi?
Yeah, just a comment. Obviously, I agree with what Hassan mentioned, but I think what you're trying to do as well is take each one at a time and analyzing it. And when we come to the energy consumption of RO, I tend to agree with Francesco that 2 kilowatt hour should be a target that we strive for. It's going to be extremely difficult. Osmotic pressure is high, but we can get there. And obviously, that's one of the routes, and the rest are many, like Hassan mentioned, holistically, the pipes, non-revenue, leakages, usages, the way people think of the usages. Lots of things can be done, of course.
Just due to this question, I just received from the floor a question. In anticipation of the COP in Paris at the end of the year, what kind of commitment would you all like to see made this year about the sustainable desalination? It's really an open question. It's difficult because we need to take some commitments, of course, in the city I live, in Paris, but this is the next target. What do you think? Who is the first just to take the relay in it?
Well, I'd like to say that sustainable desalination is a very big word.
Yes.
Sustainable desalination needs...
And also reuse.
Of course, fossil, needs power, needs energy, needs reduced footprint. So what's the challenge? I guess to reduce them all, and renewable energy is very important for us. And that's what we're discussing here as well, to reduce the power consumption to the minimum, reduce the impact. I think Dr. Kurihara was talking about a megaton of issues to do with environmental as well, not only the carbon footprint, but also the chemicals, making sure that we reduce the chemicals, reuse them if we can.
I think, unfortunately, within the panel, I think we are all within the contract business. I would say we are more the one who produce than the one who order. So following what I have explained during my small presentation, I think the commitment has really to come from the water institution and the stakeholder who are owning those plants. What I was saying, if you, by just changing the methodology of an old plant, you can produce twice the quantity, the sustainability, the environment, the energy saving is there, So it's a question of who is really ready to take this commitment.
Ghassan?
I would like to repeat or ask you to remember what Dr. Ibrahim has said earlier on. The solution is not just one thing. The solution is for sustainability is to be able to sustain the thing. And this can only be done by a mixture of things put all together. We need renewable. We need to have fossil fuel. We need all sorts of things done at the same time. We have to think efficiency at the end of the day. And once we put the efficiency to really its ultimate, then automatically we become sustainable. Efficiency is the buzzword, and we should apply it to everything we are doing. I think that probably sums it all. Thank you.
I think it's a key point. I think that's the moment just to go to the floor if anybody has a question. Dr. Kurihara, there's a microphone.
I would like to comment for the discussion. At first, the energy reduction. I also mentioned about 20% or 30% like that. But important one is what is the target or benchmark? Benchmark itself is already moving. So 5 years ago, 4 kilowatt hour per square meter were like that. But now more and more slowly. So my presentation always initial target like this, then 20% down or 30% down. So at least right now, below 3 point is necessary, I think. And Miguel-san explained, you are professional at the international symposium. We have to discuss energy point of view. We have to divide the total CO2 system itself. We have to, what kind of the energy consumption. Only part of the SWRO, many people show 2.0 or 1.75 like that. Especially in USA, they use as 1.75. This is the only part of SWR. So total process energy consumption or only part of RO, we have to divide the discussion. That's one point. And the second point is Michel-san explained, you are not scientist. And Gassan-san, I'm not scientist. So I reply to you as a scientist, one of scientists. Megaton project is not only the SWRO. If we consider water cycle for 21st centuries, we have to always take care of the water reclamation. That's why the sustainable desalination, sustainable water reclamation need more and more scientific approach. So if I say, in case of the water reclamation, I don't mention anything about that, but today I report as a point of the megaton system. Right now, membrane process, UF plus RO or MBR, that's the energy consuming process. But near future, energy production system or wastewater reclamation. That's why Megaton did as a scientist. But we have no time to explanation. During such a research project, of course, Fujiwara-san, Toyobo, and Torei is the same group. So forward osmosis we used for the concentration of wastewater treatment. This is best way. And also energy recovery by using CRO, pressure retarded osmosis, is very close to the commercialization. I would say this year or next year, 10,000 cubic feet plant will be available in Japan. That's very close. That's my...
Thank you, Kurihara-san. I think the more difficult in this kind of commitment is just to have the benchmark, to put into accord everyone. What is the reference? Because energy consumption in every of the process, either thermal or by membrane, they need to reference what is salinity, recovery rate. So we need to normalize this kind of thing. But I think the general trend is just to be reduced. I know just some offer who is lower than 2 kilowatt-hour per cubic meter per hour, only one pass, because we need to put the conditions just to compare the things. So, but I think it's achievable, but it's my personal belong. But I think one thing is quite independent just to take a reference. That's the cost, the price, the water price. I think is one of the things. Before waiting to another question, I put just a question to all the panelists. It's now we here in Middle East we have a lot of projects in IWPP, so linking the PPPs and energy and water. What do you think? In order to be more profitable in everything, it's better just to split this kind of bits, just to have an independent bit only for the desalination plant, not linked with the power plant in order to do different the price to optimize both of them. What is you think? It's better just to have IWPP or separate projects for BOTs?
I will take a little bit longer to answer it by answering in a different way. You need to get things together to really get the maximum efficiency, and in the case IWPP, to have an interest in really applying all the technology to make more, to sweat your assets more. I'll give you a small example. I'll take it as quickly as I can. We have the sewage treatment plant in Ajman, where we are totally the owners. So we ensure not only that we treat it, even before we treat it, we would like to ensure that the maximum amount of water which is delivered to the system, delivered to the houses, comes to the sewage treatment plant. That's our first priority. I'll tell you why that is. Then the next thing is we try to use the minimum amount of electricity and chemicals in the process. Because as a private sector, we are even incentivize our people to make sure that we have the best treatment for the lowest possible consumables. But we go a stage further because we are the people who are commercializing the TSE afterwards. We make sure that nothing is lost. This is treated to the right, just to the right amount of treatment, which is needed by the market. So the more and more, in general, you globalize your product and its uses, and down the line, the more economy you get in scale and in the various processes. So yes, in a roundabout way, I think IWPPs extended even to sewage treatment plant are the best way forward, because you can even add something which we didn't talk about, production of energy, because sludge is really something valuable. We can biogas and do all sorts of things. So the more you put in, the better it is for the IWPP model, which needs to be, the name needs to be changed, IWPP plus sewage plus. Thank you.
With the limit, I will say that sometimes the bankers, are not so ready to take the challenge to use, technologies which, people are confident that they are adequate, but they consider that there are some risk and therefore increase, the rate of the money or put some constraints that put the PPP, at risk. So I think
it's less
a bit
bankable.
debatable, huh?
It's less bankable, the
That
wastewater
will
reuse.
be to my next subject, pet subject, we'll always talk about the problem with IWPPs. Once you get the financial model working, nobody wants to touch it. Nobody wants to improve the efficiency. That's it. The bankers get their money. The financial model is working. There is no new technology admissible. The banks are, that's what we suffer more all the time. So there's something which needs to be rethought.
Francisco, do you think is the same for the renewable energies if you are considering that to do a IWPP renewable energies and desalination?
Being honest, I think we can mention what is the real problem. The real problem is that we have different purposes. The banks, they have one objective. The ones that are dealing with the power plant, they have another objective. And we are the weakest part, because water is just a small part of it. So, first of all, we have to start thinking in a different way and try to put those three focus that are totally divergent, try to convert them a little bit. If we are able to do that, we will take advantage of it. But if not, water, we are the weakest part, and we are just somebody that we have to do it because they need it. But we cannot take advantage of what we can offer.
And your forecast is just you get less energy cost and water cost independently, or join both BOTs?
If we think on big figures, probably we have to think on doing power in the place. I'm talking about renewable energy in a place that is more suitable for that. And desalination, talking about seawater desalination, we have to be very close to the sea. If we are very close to the sea, the transmittance of the solar energy is not as good as we wish. But if we are talking about specific areas, specific niche, probably we can find a solution that we can mix both. But I'm talking about very small power plants and very small water plants. And probably we can find much more synergies thinking on water reclamation. Because water reclamation requires energy, the amount of energy that it requires is less, and we don't need to be close to the sea. Thanks.
Fadi, do you have?
Well, I'll comment on the question that you asked, which I assume was based on whether power and water should be done together at WPP. And my answer simply is that if everything is equal, and by mean everything is equal, I mean the users of water and the users of power are all in the same place, it remains best to put them together, because the economy of scale, because of people start thinking holistically, like Hassan gave the example, where you have to make sure that the power and the water work together and you have the best efficiencies. But I truly believe that most of the times things are not equal, and the users of the water may be more or less than the users of the power, and the location of the water may be closer or further on the use of the power, and you end up in this whole phobia of transmission lines and pumping and leakages and returns. So most of the time they're not equal, but if they are, yes, I'll go for them together.
And the demand is not the same, no? Of energy and water, no? At the same time.
True.
There is some additional question from the floor. That's there.
Good evening. We have a lot of focus.
Could you introduce yourself first?
Yeah. Hi, my name is Navya Thomas. I work as a process engineer with ACOM Consultancy. We have a lot of focus on the energy, and since we are in the Middle East and we are blessed with a lot of sunlight, I would like to ask the panelists what they see as the future for solar power desalination in terms of the commercialization and the scale.
I think for you the question.
I really think that we should find a combination between solar energy and seawater desalination. As I mentioned before, when we are talking about big seawater desalination plants, to have them on the same place is not a good solution because of the reason I have mentioned before. The transmittance is not good. Probably we have to have them in the place that the efficiency is much better and to connect through the grid. On that sense, somehow we are forced to use reverse osmosis desalination, but today reverse osmosis desalination is a reliable solution for this area. If we think on that we are in the middle of somewhere and we have to use the wastewater, or we have to work on brackish waters, on that case we can try to put together and we can take advantage of the synergies in there. But that should be a case-by-case study, and probably is not the great solution that we are thinking right now.
We have another question here, Leon Aberbrook.
It's about time.
Yes, that's the microphone. Thank you.
Leon Auerbach, Leading Edge Technology. In reality, although on surface, you are absolutely right. Desalination has to be on the shore, seawater desalination, and the solar energy tends to be in the desert. There are many solutions, both to bring and couple the solar energy, particularly thermal, to desalination. And some of them would come out as a result of development. There's many ideas of low temperature desalination, including MED, and not to mention other water solutions, which will allow coupling and long-distance transmission of hot water to the desalination plants. So we are not necessarily bound by RO photovoltaic, which has the problem with storage of energy. We should look both for solar photovoltaic, we should look for thermal solution with MED and other thermal technology. So solution down the road is solar energy for many reasons, and we need to spend the efforts to really come out with innovative solution to couple those energy and water together. Thank you.
Thank you, Leon. There is some additional question. I have a lot of pending questions just to propose, but we have only 4 minutes or 3 minutes just to finish our panel. I propose something more simple, is looking for the future for desalination water reuse. Could you summarize in only 1 or 2 words what is our future in this market, in desalination water reuse? Who would like just to do the first in it?
I think on water reuse, I'm quite confident that now the community is more and more focused on the zero liquid discharge approach. Mm-hmm. You know, I have been fortunate to participate to a large project in Qatar, you know, for Shell on a GTL project which was a zero liquid discharge project. And now, in fact, in Qatar, the whole Ras Laffan area is now ZLD, and therefore will force the people to look at this way of thinking, and obviously will give a big boost to the water reuse business.
Water reuse business, just to
For the industrial, more for the industrial use.
Gassan?
Yes, I would like to be more, again, I think the whole thing can be resolved itself once subsidies are out of the way. Because once subsidies are out of the way, water reuse will find its own place. It's very cost effective, and it will just flourish. And unless we get rid of subsidies, we are suffering day and night in the choice of equipment, in the choice of feeder, in choice of everything we're doing. So my appeal, again, in the place of over-subsidized country, please, let's wind the subsidies down, and water reuse will become really just find its own way into the market.
So remove subsidize and let's talk the market.
Yes,
The water price.
concentrated where it's useful. You know, why should somebody who has plenty of money receive the same kind of subsidy as somebody who is really on the breadline? That is a question which subsidy does not answer. Thank you.
Nobuya-san?
Yes, as you said, I think in the future, so water reuse is more important than CO2 desalination. So not water reuse, water, how can I say, recirculation. So, but in this sense, so that in the future, so that so treated wastewater, we have to. Well, we may to drink should be potable water to complete this water circulation. Yeah.
Fadi?
Well, I see the future in desalination, people focusing more and more into efficiency and building larger plants and going to various parts of the world that never been there because of the weather changing, climate changing. On the wastewater reuse, I see a huge market opening up, applications widening and widening in various aspects of industrial and even municipal.
Francisco?
What I see is that the natural source of water is very limited. At the beginning, when we talk about seawater desalination, that was a non-conventional source of water. Today, almost everybody is talking about desalination, and we are considering that as a natural source of water. The next step is, shall we do the same with other non-conventional sources of water, like wastewater? And shall we reclaim it properly? And I think we should work a little bit more on that in order to make reuse of water or water reclaiming as a natural source of water. And if we are able to combine that with renewable energies, we will do a lot of we will help a lot this world to be sustainable.
I think, thank you. I think I like just to summarize the future for us. For me, it's a promising market because we are working for the sustainability. So it's a very good job for all of us. Okay, we are working in this market. I would like, with only 1 minute delayed, I would like all of the panelists just to join us to debate here, and of course, all the attendants to this conference and to both ideation of about desalination and water reuse. Thank you very much for all of you. Thank you.